Hey seniors, today we're going to start talking about this idea of rational and irrational numbers. So let's go ahead and jump right in. On your notes page on the left-hand side, go ahead and draw your line and go ahead and write rational numbers in the top left-hand corner. So in life, you're going to meet people who are rational and irrational. In other words, you're going to meet people that make a lot of sense and people that might be a little confusing. Numbers are the same way. So our job today is to be able to recognize rational and irrational numbers. So let's go ahead and start with rational numbers. All rational numbers can be represented as a fraction. I want you to write that bullet point down on your notes page. Pause the video if you need to. Rational numbers must also terminate or repeat. And terminate is just a fancy word for stop. So let's use an example. Let's take 6. 6 is a rational number. If I wanted to represent it as a fraction, I would just put it over 1. And I see that 6 does terminate. There are no numbers that come after it. So I know that it's a rational number. All right, let's use 3/4. All right, 3/4 is a fraction. So I know it must be rational. If I wanted to write it as a decimal, it would be 0.75. And since 5 terminates in the 100ths place, I know that the number is rational. Let's do one more. If I had negative 2.5, I see immediately that 5 terminates in the 10ths place. So I know the number is definitely rational. If I wanted to represent it as a fraction, I would go through our process from yesterday, and I would come out with negative 2.5. So since this number can be written as a fraction, it's definitely rational. All right, let's talk about rational numbers that do not terminate. So if I had 1/3, this is the most famous example of a rational number that repeats. I know that it's a fraction, so it must be rational. But if I were to rewrite this as a decimal, it would be 0.33 forever and ever and ever. So 3 repeats forever and ever and ever. And you see this little bar that I drew above 3? That just means that 3 goes on forever and ever. So even though this number does not terminate, it repeats. And since it repeats, it's a rational number. Let's move on. All right, let's talk about irrational numbers. Irrational numbers do not terminate or repeat. Write that down on your notes page. Pause the video if you need to. The most famous irrational number is pi. You don't have to write that, but I do want you to write pi and then draw the symbol for pi, which is this little funky symbol here. And this is the decimal for pi, 3.14, and then a bunch of numbers that continue forever and ever and never repeat. So since the numbers behind the decimal do not terminate or repeat, it's an irrational number. All right, let's do an example. All right. Go ahead and write on your page example 1. Choose the number that is rational. All right, if I'm looking for a rational number, I know I'm looking for a number that can be represented as a fraction and also one that either terminates or repeats. So let's go ahead and immediately eliminate some choices. All right, B, 3.148932, and then the ... means the numbers go on forever. None of these numbers repeat, and since they go on forever, I can go ahead and eliminate that choice because that can't be rational if the numbers go on forever and they don't repeat. C, pi. I know that pi is irrational. So that leaves me with A and D, and both of them are represented as fractions. However, I see that D is 7 pi over 4. Write that a little bit clearer for you guys. 7 pi over 4. Even though this is represented as a fraction, because of the pi symbol, I know that this number is irrational. So I can go ahead and eliminate D as a choice. So that leaves me with A, which is represented as a fraction with no pi symbols. That's a rational number. Let's do another one. All right, choose the number that is irrational. All right, well, let's again go through. I know that irrational numbers don't terminate and don't repeat. So I can go ahead and eliminate A because I see that 4 terminates in the thousandths place, and irrational numbers don't terminate. B, 5.867, and remember, the line means that those numbers repeat. So if I were to rewrite it again, those numbers would repeat forever and ever and ever and ever. But since they repeat, it's rational. So I can eliminate B as a choice. C, the square root of 81. I'm thinking back to last week, and I know that the square root of 81 is 9. 9 terminates right there. It's definitely a rational number, so I can go ahead and eliminate C as a choice. That leaves me with D. And of course, I look past my decimal, and I see that the numbers go on forever and ever and ever because of the ... at the end. So D is my answer choice. And that's literally it. Look for numbers that don't terminate and don't repeat. Those are always irrational. And rational numbers are ones that you can repeat, that you can show as a fraction, and ones that do terminate and repeat. All right, that's it for me. It's time for you guys to practice.